For a moment, try to imagine light that left its source before modern humans appeared on Earth. Tonight, that light is traveling directly toward you. And if you know where to look, you can see it with your own eyes. We are talking about the Andromeda Galaxy, the nearest large galaxy to our own. Andromeda is a spiral galaxy with a structure similar to that of the Milky Way, the galaxy in which we live. It is located approximately 2.5 million light-years away. Despite this enormous distance, it is so large and bright that on a clear, dark night, you can find it without a telescope as a faint, hazy patch in the constellation Andromeda, from which it takes its name. It is one of the most distant permanent objects that a person can see with the naked eye under good conditions. People noticed this galaxy a very long time ago, although they had no idea what they were actually observing. As early as the 10th century, the Persian astronomer al-Sufi described it in his work as a small cloud in the sky. For centuries, people assumed that it was some kind of nebula, a cloud of gas located somewhere inside our own galaxy. This idea only began to change at the beginning of the 20th century, when the so-called Great Debate divided astronomers. One group of scientists argued that similar hazy patches in the sky were part of the Milky Way. The other believed they were separate, enormously distant galaxies, isolated island universes far beyond our own. The answer came from astronomer Edwin Hubble during the 1920s. In Andromeda, he identified variable stars known as Cepheids. Their true luminosity can be determined from the regular pattern with which their brightness changes, thanks to a relationship previously discovered by astronomer Henrietta Swan-Leavitt. Hubble was therefore able to estimate the distance to Andromeda and demonstrate that it lay far beyond the boundaries of the Milky Way. Andromeda became one of the decisive pieces of evidence showing that the universe was far larger than most people at the time had ever imagined. So how large is Andromeda really? Its exact boundary is not easy to determine. It depends on whether we count only the bright stellar disk or also the extremely faint outer structures and galactic halo. These may extend across a distance of more than 200,000 light-years. Andromeda probably contains approximately 1 trillion stars, or 1,000 billion, while estimates for the Milky Way usually range between 100 and 400 billion stars. Despite containing more stars, however, the total masses of the two galaxies may be comparable, because most of their mass does not come from stars but from invisible dark matter. Like our own galaxy, Andromeda contains prominent spiral and ring-like structures filled with stars, gas and dark lanes of interstellar dust. From Earth, we see its disk at a steep angle, which makes the galaxy appear elongated. If our eyes could detect its faint outer regions, Andromeda would stretch across approximately 6 full moon diameters in the night sky. Most of the galaxy is simply too faint to see, so we normally observe only its bright central region. Yet even these enormous dimensions describe mainly the stars we can observe. Beyond Andromeda's visible disk lies a vast, almost invisible envelope of ionized gas. Measurements made with the Hubble Space Telescope suggest that this gaseous halo extends approximately 1.3 million light-years from the galaxy and reaches as far as 2 million light-years in some directions. Astronomers mapped it indirectly by observing ultraviolet light from distant quasars and measuring how the gas absorbed part of that light. The halo contains material expelled by dying stars and supernova explosions, as well as gas that may eventually contribute to future star formation. Because Andromeda is only 2.5 million light-years away, its enormous halo may already be beginning to interact with the similar gaseous halo surrounding the Milky Way. Like most large galaxies, Andromeda did not form all at once. It developed gradually over billions of years by merging with smaller galaxies and groups of stars that it gravitationally attracted and slowly absorbed. Traces of this turbulent past remain visible today. Astronomers have discovered structures around it known as stellar streams, long trails of stars that once belonged to smaller galaxies before Andromeda tore them apart with its gravity and gradually absorbed them. These streams act like cosmic scars, revealing the galaxies Andromeda encountered in its past. The most prominent example is the giant Southern Stream. Some models suggest that Andromeda experienced a significant galactic merger approximately 2 to 3 billion years ago. The smaller galaxy M32 may be the surviving core of a larger object that Andromeda tore apart during such an event. However, this idea has not yet been definitively confirmed, and astronomers are still piecing together Andromeda's past from its surviving stellar streams and the motion of its stars. At the very center of Andromeda lies an enormous black hole that astronomers call M31 star. Its mass is estimated to be between approximately 100 and 140 million times the mass of the Sun. This makes it roughly 25 to 30 times more massive than the black hole at the center of our own galaxy, known as Sagittarius A star, which has a mass of approximately 4.3 million suns. The center of Andromeda also hides a strange feature that astronomers were unable to explain for a long time. Instead of one bright nucleus, observations appeared to reveal two separate points of light located close together. Today, scientists believe that these are not two different black holes, but a single black hole surrounded by a complex and asymmetrical arrangement of stars. The eccentric distribution of older red stars creates the appearance of a double nucleus, while a smaller disk of young blue stars lies closer to the black hole. Andromeda does not travel through space alone. It is accompanied by an entire group of smaller satellite galaxies moving within its gravitational field. Among the most prominent are M32 and M110, both clearly visible in many photographs of Andromeda as small, bright patches near the galaxy. In addition to these, Andromeda is accompanied by dozens of other, much fainter dwarf galaxies. Its gravity gradually deforms and stretches these smaller galaxies, sometimes tearing away stars that may later become part of Andromeda itself. And now we come to the question that perhaps interests people most. Is Andromeda approaching us? Yes, it is. After accounting for the Sun's motion within the Milky Way, Andromeda is approaching our galaxy at approximately 110 kilometers per second. For many years, astronomers assumed that this motion meant the two galaxies would inevitably collide and eventually merge several billion years from now. However, newer research published in 2025, using measurements from the Hubble and Gaia space telescopes and accounting for the gravitational influence of M33 and the Large Magellanic Cloud, produced a surprising result. According to the simulations, the probability that Andromeda and the Milky Way will merge during the next 10 billion years is only slightly higher than 50%. In almost half of the simulated scenarios, the two galaxies do not merge at all during that period. The outcome depends on extremely small and still imprecisely measured differences in the motion, position and mass of the individual galaxies. If Andromeda and the Milky Way did merge, their individual stars would probably not collide directly because the distances between them are enormous. Their gravitational interaction would, however, completely transform the shapes of both galaxies, mix their stars and potentially bring their central black holes together. The fate of our galaxy is therefore not as certain as it appeared until recently. Andromeda is far more than a faint patch in the night sky. Observations of this galaxy played a crucial role approximately 100 years ago in revealing the true scale of the universe. They demonstrated that the Milky Way is not the entire universe, but merely one galaxy among an enormous number of others. And perhaps one day, billions of years into the future, Andromeda will dramatically change the appearance of our galaxy. Whether the two galaxies eventually merge or remain separate, one thing is certain. Andromeda and the Milky Way are the two dominant galaxies of our local group, and their gravity influences both their movement and their future. Thanks for watching, and I'll see you next time.